Welcome to Astronomy Daily, your daily dose of space and astronomy news. This is Anna, bringing you the latest updates on cosmic discoveries, space missions, and lunar exploration. Today, we've got a bumper lineup of stories that span our cosmic neighborhood and beyond. We'll be exploring new research suggesting that one of our neighboring galaxies might be literally tearing another apart, hear firsthand accounts from the first humans to orbit Earth's poles, and learn about China's ambitious plans to 3D print building materials on the lunar surface. Plus, we'll dive into a surprising discovery from the James Webb Space Telescope about a planet's demise, and look at innovative robots that could soon be exploring beneath the moon's surface. So sit back and prepare for a journey through the latest developments in our understanding of the universe. Our first story takes us to our cosmic neighborhood, where a galactic drama is unfolding. If you've ever been lucky enough to view the night sky from the southern hemisphere, you might have spotted two fuzzy patches of light. These are the Magellanic Cloud satellite galaxies that orbit our own Milky Way like bees around a hive. New research from Japan has revealed something quite remarkable about these celestial neighbors. Scientists now believe that the Large Magellanic Cloud, or LMC, might actually be tearing apart its smaller companion, the Small Magellanic Cloud. Associate Professor Kengo Tachihara and his team at Nagoya University used data from the Gaia Space Telescope to track the movements of over 7,000 massive stars in the Small Magellanic Cloud. These aren't just any stars. They're giants more than 8 times the size of our sun, young enough that they typically live only a few million years before exploding as supernovae. What they discovered was startling. The stars in the SMC were moving in opposite directions on either side of the galaxy, as if being pulled apart by some invisible force. Some stars are approaching the Large Magellanic Cloud, while others are moving away from it, strong evidence of the larger galaxy's gravitational influence. When we first got this result, we suspected that there might be an error in our method of analysis, Tachihara admitted. But the data was clear. The SMC appears to be undergoing a slow-motion destruction. Perhaps even more surprising was the finding that these massive stars, and likely the interstellar gas from which they formed, don't follow a rotational pattern. This suggests the Small Magellanic Cloud itself doesn't rotate as previously thought. As researcher Satoya Nakano points out, this could potentially change our understanding of the three-way interaction between the Magellanic Clouds and our own Milky Way galaxy. The findings offer us a rare front-row seat to cosmic disruption in action, and may help astronomers better understand how galaxies evolve through gravitational interactions, a process happening throughout the universe, but rarely observable in such detail. Next, let's get an update on the Fram 2 mission, which just concluded. The first humans to ever experience a polar orbit of our planet are now sharing what it was like to see Earth from this unique vantage point. The Fram 2 mission, named after the famous polar exploration vessel, launched on March 31st, 2025, with SpaceX's Crew Dragon Resilience carrying an international crew of 4 on their groundbreaking journey. Unlike typical space missions that orbit roughly along Earth's equator, this crew ventured into a 90-degree inclined orbit, taking them directly over the North and South Poles during their 3.5-day mission. This unprecedented trajectory gave them an entirely different perspective on our home planet. Mission Commander Chun Wang, who self-funded this historic flight, described the experience in vivid terms. People say Earth is a blue marble, a blue planet, but to us in polar orbit, it's more like a frozen planet. It gives you a feeling of not the Earth, but another planet, an icy planet such as Jupiter or Saturn's moons. The crew, all of whom had previously completed expeditions to both Earth's poles on the ground, found themselves surprised by the stark difference between their expectations and reality. Medical officer and mission specialist Eric Phillips noted, "I was expecting to see a lot more of the Earth, the brown Earth within the polar regions. When we looked at it from above, it was completely white. This is one of the most stark contrasts between the images that we see online of these various polar locations and what we experienced." Orientation proved particularly challenging in this unusual orbit. Vehicle Commander Jannica Mikkelsen recalled struggling to recognize her home in Svalbard, an archipelago in the Arctic Ocean. It took a few seconds before we identified it because, depending on how we are positioned in the cupola, we're seeing it upside down, left, right, whatever. Now, this disorientation wasn't just a curiosity. It was part of several experiments conducted during the flight. The crew tested methods to reduce space adaptation sickness by finding familiar orientations. They also studied the aurora from above, capturing images of what Michelson called ghost auroras and the wavelengths that go perpendicular to the aurora and the magnetic field. Interestingly, Wang noted that despite their privileged position, the auroras are beautiful from the capsule, but I think all Earthlings have the best perspective of auroras from the surface. The mission concluded with another first. The Crew Dragon splashed down in the Pacific Ocean rather than the Atlantic, part of SpaceX's transition to West Coast recovery operations. The crew attempted to exit the capsule independently, but quickly discovered how challenging readaptation to gravity could be after even such a short mission. "I was so disappointed in my own body after only 3.5 days," Michelson admitted. "My body had completely forgotten what it's known its whole life, and that's gravity." Next up, China is preparing to take a significant step toward establishing a human presence on the moon with plans to 3D print building materials using lunar soil. The Chang'e 8 spacecraft, scheduled to launch around 2028, will carry revolutionary technology designed to transform the moon's surface material into construction bricks without bringing manufacturing equipment from Earth. Wu Weiren, chief designer of the Chinese Lunar Exploration Program, recently revealed details about this ambitious project. Now we have developed the world's first device that produces bricks made of lunar soil. This system harnesses sunlight, collects solar energy, and transmits it to the moon using fiber optics, Wu explained. The ingenious system works by concentrating sunlight to achieve temperatures between 1400 to 1500 degrees Celsius, hot enough to melt lunar soil. The device then uses 3D printing technology to shape this molten material into bricks of various specifications. What makes this approach particularly valuable is that it eliminates the need to transport water and other materials from Earth, significantly reducing mission costs. This technology represents a major advancement in what space agencies call in situ resource utilization, the practice of using materials already present at the destination, rather than carrying everything from Earth. Given the extreme expense of launching anything into space, utilizing lunar resources could dramatically expand possibilities for sustainable lunar exploration and eventual habitation. The brick-making experiment is part of China's broader lunar exploration roadmap. Before Chang'e 8's brick-making mission, China will launch Chang'e 7 in 2026 to explore resources at the moon's south pole, with a particular focus on searching for water ice. If substantial water is found, it could provide drinking water, oxygen, and even rocket fuel for future missions. China has already begun testing the concept on a smaller scale. The country has sent samples of bricks made from lunar soil simulant to its Tiangong space station, where they'll remain exposed to the harsh conditions of space for 3 years to test their durability. These efforts follow China's impressive series of successful lunar missions, including the historic Chang'e 6 far side sample return last year. The country is also planning to land its first astronauts on the lunar surface before 2030, potentially using technologies like these 3D printed bricks to establish more permanent infrastructure. Moving on. In an astronomical plot twist, NASA's James Webb Space Telescope has rewritten our understanding of what happens when a star devours a planet. Observing what scientists believe to be the first star caught in the act of swallowing a planet, Webb has revealed a surprising mechanism behind this cosmic catastrophe. Located about 12,000 light-years away in our Milky Way galaxy, the star system known as ZTF SLRN 2020 was originally spotted when it flashed brightly in optical light. Initial theories suggested that as the star aged, it had swelled into a red giant, gradually engulfing its nearby planet, a process astronomers believed might one day happen to our own inner planets as the sun expands. However, Webb's mid-infrared instrument, MIRI, told a completely different story. With its unprecedented sensitivity and resolution, Webb measured the hidden emission from the star with remarkable precision. What the telescope found was that the star wasn't as bright as it should have been if it had evolved into a red giant. This means there was no stellar swelling to envelop the planet as previously thought. Instead, Webb's data suggests that the Jupiter-sized planet's orbit gradually decayed over millions of years, bringing it closer and closer to its star, much closer than Mercury orbits our sun. Eventually, the planet began grazing the star's atmosphere, triggering a runaway process. The planet, as it's falling in, started to sort of smear around the star, explained team member Morgan McLeod of the Harvard-Smithsonian Center for Astrophysics. This final planetary plunge blasted gas from the star's outer layers, which expanded and cooled, forming a cloud of dust over the following year. Webb's near-infrared spectrograph added another surprise, detecting a hot circumstellar disk of molecular gas containing carbon monoxide, reminiscent of a planet-forming region, though planets certainly aren't forming here. This cosmic autopsy provides valuable insights into the fate that might await planets in other systems and potentially our own solar system in the distant future. The researchers hope this is just the beginning of understanding these dramatic stellar events, with NASA's upcoming Nancy Grace Roman Space Telescope expected to detect more examples of stars consuming their planetary companions. Finally today, we head back to the moon for a look at some more innovation. Our understanding of the moon has advanced considerably thanks to the Apollo missions and robotic explorers, but there's still much to learn about our closest celestial neighbor. To tackle this knowledge gap and prepare for future lunar habitation, scientists are now proposing an innovative exploration method: subsurface robots. A team of researchers has developed a concept called Pleaser Persistent Lunar Exploration with Autonomous Subsurface Robots. This mission would feature a snake-like robot specifically designed to penetrate the lunar regolith, allowing unprecedented access to what lies beneath the moon's surface. Unlike traditional rovers that can only study surface features, Pleaser would be able to burrow into the regolith and even slither into skylights, collapsed sections that provide access to underground lava tubes. These subsurface caverns are particularly exciting as potential sites for future lunar bases, since they offer natural protection from the harsh lunar environment. Just like on Earth, the different layers tell the history of the area you are in, explains Jared Longfox, a planetary exploration research scientist involved in the research. On the moon, there is no wind or flowing water, so the main processes that shape the surface are impacts. The robot's snake-like configuration would allow it to measure critical properties of the lunar soil, including strength, thermal conductivity, and dielectric properties. It could also detect the presence of valuable resources like water ice, crucial for sustainable lunar exploration and habitation. For power, the team has explored multiple options. One intriguing design features solar panels embedded along the robot's body that could be deployed when it surfaces to bathe in the sun. This would allow the robot to operate during lunar daytime while exploring the subsurface regardless of external conditions. Beyond scientific discovery, these robots could identify areas suitable for developing lunar infrastructure like habitats, roadways, and landing pads. They could even deploy subsurface sensors like seismometers to study the moon's interior structure, instruments that are notoriously difficult to place effectively on the surface. Looking further ahead, researcher Adrian Stoica speculates that advanced versions of these robots might someday create subsurface tunnels for lunar habitats. These may be like the machines that build underground tunnels, but perhaps more in the formation of teams rather than a big machine, he suggests. As we plan for a sustained human presence on the moon, these subsurface explorers could prove essential in both unlocking the secrets of lunar geology and paving the way for our future among the stars. But isn't it a wild idea that sounds plausible? That wraps up our cosmic journey for today. What a remarkable collection of stories that remind us just how dynamic our universe truly is. From the Large Magellanic Cloud potentially tearing apart its smaller companion, to humans experiencing Earth from polar orbit for the first time, we're constantly gaining new perspectives on our place in the cosmos. The innovations we discussed today paint an exciting picture of our future in space. China's plans to 3D print bricks from lunar soil by 2028 could revolutionize how we approach building off-world. Meanwhile, the proposed snake-like Pleaser robots might soon be slithering beneath the lunar surface, uncovering secrets hidden for billions of years. Perhaps most humbling is Webb's observation of a planet's final moments as it spiraled into its star. These cosmic autopsies not only satisfy our curiosity, but also provide glimpses into possible futures for planetary systems throughout the universe, including our own. The pace of discovery in astronomy and space exploration continues to accelerate, revealing a universe more complex and fascinating than we ever imagined. Each new finding raises fresh questions and ignites our desire to explore further. This is Anna, having been your host on Astronomy Daily. And today, a small request from me to you. If you're enjoying Astronomy Daily, how about sharing us with any family or friends who you think might get some benefit from our stories and news updates? I'd really appreciate that. And with that, I'm out of here. Thank you for joining me on this journey through the cosmos. Until next time, keep looking up.